Welcome to the beginning of chapter 5. So chapter 5, we're going to be talking all about polynomials, okay? Polynomial functions. And so one of the biggest things on this first day is getting a common vocabulary. There's going to be a lot of language and vocab we're going to be using throughout this chapter. So the first day is really just taking an opportunity to make sure we understand what that vocabulary is. So diving right in. The first thing that you need to know is the term monomial, which again, hopefully is kind of a throwback to Expo, because I know you've seen this before. But all a monomial means is a real number, a variable, or a product of a real number with one or more variables with whole number exponents. So that sounds a little bit wordy, right? Basically, all we're looking for seems like 4y. That would be an example of a monomial, just a number multiplying with a variable. 1/2. Okay, you could just have a real number, and that can be a monomial. 6x squared. Okay, remember the variable can have an exponent, a whole number exponent, and still be a monomial. Or you can even have multiple variables, -3xy. This is going to be less common for us to talk about throughout this chapter. However, just be aware this is a situation that can occur. So whenever we're talking about monomials, you should also recall the degree, okay? And degree is the exponent, okay? That's going to be the biggest key here. So remembering when we're talking about degree, degree is always referencing the exponent. So for the first one, the exponent is 6. So that means the degree is 6. For 6x squared has an exponent of 2, so it has a degree of 2. 5x. So remember, if there's no exponent showing, remember that actually means that there's a secret 1 there. So that would have a degree of 1. And then hopefully you'll kind of follow along that if there's no variable at all, so 9 doesn't even have a variable, that means a degree of 0. And that's true for any constant because it doesn't have a variable whatsoever. Now, what about when we start putting these things together? Well, that's where this big term polynomial comes from, okay? A polynomial is simply a monomial or the sum and difference of monomials. So now we're going to be combining these things together. For example, 4x squared minus 3, two monomials put together. -5x cubed plus 4x squared minus 6x plus 7. Again, just a combination of a bunch of monomials added and subtracted together. So that's all that a polynomial means. And again, you've been dealing with this a lot. Expo, I'm sure you saw this in geometry. You've already been working with them in Algebra 2. We just haven't been using this language yet. Then obviously when we talked about a monomial, we talked about the degree. So now that we're talking about a polynomial, we should also reference the degree. And the degree is kind of the same idea, okay? The degree is going to be the largest exponent, okay? That's essentially what we mean when we talk about the degree. We're looking for the largest exponent this time when we're referencing a polynomial. So that first one, 5x squared plus 6x minus 3. Well, here is the largest exponent, that 2. Therefore, the degree is 2. -3x to the fourth plus 5x minus 1. Again, I identified the largest exponent, so this time it is 4, so the degree is 4. So none of this is difficult. All of this you've actually seen before, but we just want to make sure we have that refresher so we have that common language as we keep moving forward. So there's something else that you've been doing for quite a while. But we do want to make sure we take an opportunity to review it. And that idea is standard form, okay? In standard form, it arranges the terms by degree in descending order, meaning start with the largest and you end with the smallest, okay? We'll come back to this visual in just a little bit, that nice little diagram. But basically, there's two things you have to do to put something in standard form, all right? First step, we want to combine all like terms, which is the terms with the same degree. And then you want to arrange the terms starting with the highest degree, working to the lowest. So if you do those two things, those are the two steps to getting anything into standard form. So let's take a look at how that works. So here, the way that I do is I kind of arrange them and combine like terms at the same time. Let me show you what I mean. So here, I identified that my highest power is 2, okay? So I look for everything that has an x squared, okay? So I have a negative 1x squared and a 4x squared. Well, that's going to become a 3x squared. Then I look for the next highest power, and in this case, that would be a 2x. Now, there's nothing else that combines with it, so I can just write it there. Then, of course, always ending with the constant term. And again, there's nothing that combines with that. So I kind of do this all in one, okay? I'll look for the highest power, then I'll scan, okay, let's combine all those together, write it, move on to the next one. Now, with these powers, okay, comes a very important naming scheme. Used on the majority of these back in Expo, but there are a couple new ones that we actually didn't make you memorize back as ninth graders. So if you recall, there's two ways we can name these. Once we put them in standard form, we have two different ways of naming these. First is naming them by degree. Okay, so naming by degree is going to be this column right here. So if it's a degree 0, we just call that a constant. All right, and again, that is just when you have a number, okay? So 5, 1/2, 4, -3. If you're just looking at a number, well, you're looking at a constant. What about when it has degree 1? So that means it has an x term. We call that something linear. And again, you've seen this so much. We even spent all of chapter 2 on linear things, okay? So x plus 4, that is your example of something linear because it has that x term in it. Next up, a square is a quadratic. We also spend an entire chapter on quadratics, okay? And all that means is it has an x squared term, like their example, 4x squared. When we get up to having an x cubed, we call that cubic, okay? So if you notice their example, 4x cubed minus 2x squared plus x, it's because of that cubed that we call this a cubic. Now, these next two, these are ones that we didn't make you memorize back as ninth graders, okay? These next two terms are going to be new, so maybe it's going to be a little bit harder. You might want to spend a little bit more focus just to make sure you're catching on to these brand new ones. So the next one, quartic. Quartic is coming from that this is a fourth power, okay? And finally, quintic. Quintic comes from the fifth power, okay? So those are all of the names based on degree. Now let's look at number of terms. So the first one only has one term. One term is a monomial. The second one has two terms. So remember, we call that a binomial. This one, back down to only one term. So that is a monomial. This one has 3. So remember the prefix we use for 3, just like for a triangle, which has 3 sides, a trinomial. This next one, back down to 2. So that is a binomial. This next one has 4, okay? And remember, once we get above 3, they don't keep naming them. So we just say, hey, this is a polynomial of 4 terms, okay? They don't keep coming up with unique names for them. You'll just keep going up the ranks, polynomial of 4 terms, polynomial of 5 terms, 6 terms, so on and so forth, okay? So something that I want you to notice is all of these have some prefix and then end in nomial, okay? So monomial, binomial, trinomial. So that's how you name based on number of terms, okay? You always have that nomial, and then you just pick the proper prefix, mono, bi, tri, or if you get above that, then you just start naming how many terms they have. So let's look at the one we just did above, okay? So this, I see a square, okay? So its degree is 2, so I will name it a quadratic. And then I see 3 terms, so that would be a trinomial. So this one right here would get labeled as a quadratic trinomial. Okay, so again, the table is not difficult, and you've seen majority of these terms before. It is reacquainting ourselves with these ideas as we go. So let's look at these, okay, being able to name these things. So to name it by degree, the first thing I look at is obviously the degree. Degree 2 is going to be quadratic. Number of terms. 2 terms is going to be a binomial. So this one, quadratic binomial. What about the next one? So this one, its degree is 3. Degree 3, if you look back at your table, means it is going to be called a cubic. Number of terms, 1, 2, 3, that is going to be a trinomial. So they always get 2 names, okay? So here, cubic trinomial. Now again, the key here is you need to have it in standard form first, okay? If it's not in standard form, then it gets much harder to identify these names. So for all of these, the first thing you're going to do is put it in standard form, then we'll name them, okay? So this first one, what I notice is all of them have different degrees, okay? So I notice the 9x squared. I'm just going to write that one first, then the 3x, then the 5. Okay? So you can always write it with the highest degree first, working your way down. And now from there, naming it based on degree. Well, this is degree 2, so that would make this a quadratic. Number of terms, I see 1, 2, 3 terms. So that would make this a trinomial. Our next one, so here the highest power is going to be 4, and that's the only one that I see. So I put in my x to the 4. Then I don't see any x cubes, but I do see some x squared. So I identify those, negative 6x squared plus 10x squared. That's going to leave me with a 4x squared. Then I see a 4x, and I see a minus 12. All right, so naming it by degree. Well, here its degree is 4, so if you reference your table, you'll see that degree 4 is going to be called a quartic function. Then here, number of terms, 1, 2, 3, 4 terms. So remember, when you got up to 4 terms, now it didn't really have a special name. Now we just called this a polynomial of 4 terms. Okay, it didn't really get a special name associated with it. And our last one, standard form. So here again, all of them have different degrees already. So basically it's just rearranging them. The 5x cubed should come first, then the 2x, then the minus 1. So now to name it based on degree, well, has degree 3, making it a cubic. Number of terms, I see 1, 2, 3 terms. So that is going to be a trinomial. All right, so there is one last thing that I want to go over with you, okay? Kind of a cool thing of if you're looking at the points from a polynomial, you can use the differences in the y values to determine what degree the polynomial has, okay? Because all you have to do is keep finding differences until they're all the same, and that tells you what the degree is. So for example, on this first one, notice I've listed out all of the y values here, okay? So all the y values from the table, I just put right here. And now I want to find all of those differences, okay? So here, how do I go from -1 up to -7? Well, or down to -7? Well, I'm subtracting 6. How do I go from -7 up to -3? Well, that is adding 4. How do I go from -3 up to 5? Well, that's me going up 8. 5 up to 11, you have to add 6. 11 back down to 9, you're subtracting 2. 9 all the way down to -7, that's going to be a -16. So you want to find all those differences, okay? What are you doing to go from y value to y value? Now notice these are not all the same, okay? So the first difference, not all the same. So what that means is we have to do this process again. Okay, so we're going to do the same thing between the differences now. So we're going to find the differences of the differences. -6 to go up to 4, that's going to be adding 10. 4 up to 8, you're adding 4. 4 or 8 back down to 6, you have to subtract 2. 6 all the way down to -2, you're subtracting 8. -2 down to -16, you are subtracting 14. So again, the second difference is still not the same, okay? So we have to keep doing this process until they end up giving us all the same thing. So let's take a look at this next one. 10 to get down to 4, you're subtracting 6. 4 to get down to -2, subtracting 6. -2 down to -8, subtracting 6. -8 down to -14, you are subtracting 6. So the third differences are all the same, right? And that's what we're looking for, okay? We're looking for how many times do we have to go through this until those differences are the same. And because it is the third difference, it means that it has degree 3. So this data was made from a cubic function. Okay, so kind of a neat thing that you can tell right away what the degree of that polynomial is. So let's work out one more and then we'll call it good for the day. All right, so first thing we need to do is remember we are talking about y values. So here we need to figure out what are we doing. So for the first differences, what are we doing to go from 13 or 23 down to -16? Well, 23 down to negative 16. We're subtracting 39 to go down that far. Now look at this. Now we're going from negative 16 up to negative 15. So there we actually added 1 to do that. Negative 15 up to negative 10. For that we added 5. But now we're turning around and going back down to negative 13. For negative 13 up to negative 12. And then negative 12 up to positive 29. We'd have to add 41. So here we're just going through tracking what do we need to do to go from number to number, okay, finding those differences. Now notice these aren't consistent, okay, these aren't all the same. So the first difference didn't work. So now let's move on to the second difference. So second difference, same thing. So going from negative 39 up to positive 1, that would be going up by 40. Going from 1 up to 5 would be adding 4. From 5 down to negative 3, you would have to subtract 8 to do that. To go from negative 3 up to 1, well, negative 3 up to 1, you'd have to add 4. And to go from 1 up to 40, or sorry, up to 41, you'd have to add 40. So here we've gone through this process again, but we still don't have consistency, okay? They're still not all the same number. So let's try this again. So how do I go from 40 down to 4? Well, that would be subtracting 36. How do I go from 4 down to negative 8? I would have to subtract 12. How would I go from negative 8 back up to 4? That would be adding 12. And how do I go from 4 up to positive 40? That would be adding 36. So once again, we're still not quite where we need to be, okay? This still isn't quite what we're looking for. However, we can tell we're getting closer. So hopefully, after one more, hopefully we'll have it. So negative 36 up to negative 12. That would be adding 24. Going from negative 12 up to positive 12, so 12 plus 12 would get me going up 24. Then 12 up to 36. Again, I would be adding 24. And this time, look, now I have all the same. Those differences are all the same. So what that means is that the fourth difference is where I have that consistency. So this function comes from a degree 4 polynomial. All right, so much good stuff in here. A lot of good vocab, a neat little trick here at the end to determine what the degree is. So I want you to take a moment, write that summary for me, please. Okay, take a minute, write that summary, and then just come back to class ready to do your practice work.